Now that our environment is ready, we can start working with Octave or MATLAB. First, we must define our objects that we call variables. It can be numbers, vectors, matrices, and later we will see something else. But first you must choose a name for these variables in order to define them. It is not necessary to declare a variable. Its size and type are set automatically. So for example, if you want to set the variable at -3.4, I can simply type a equal to -3.4 and MATLAB or Octave recognizes it. I can simply define column vectors. For example, I want to use b equal to bracket -3.1 semicolon 4.9 and then I close the brackets. And here I have defined a vector b, which is a column vector 1 by 2. I can also define row vectors, like for example c equal to a row vector -2 4.67. Then I used to use the brackets, and instead of using semicolons I have to just put a space. Then I can close the brackets again. And here is my new variable. With the same principle, we can also define matrices of an arbitrary size. For example, if we want to have a matrix D equal to 2, 3, and 0 in the first line, and then in the second line, -4, 5, 6, I have to put semicolons between the two lines. But the same principle applies as before. So spaces separate columns and semicolons separate rows. When you write a program, you need variables. These variables stores values, vectors, matrices. So you need to name those variables. Before we have seen that we can say a equal to 3, and then I put a semicolon so that the variable doesn't show up, but it is there. So if I type again a, then I can recover the value. Now there are rules to name variables. So it is important to give a proper name to a variable, a name that you can recognize, but you don't have the freedom that you want. For example, you cannot name a variable starting with a number. So if I say 3a equal to 2, for example, then there is an error. Octave and MATLAB don't like that. So very important, you start with a name. But I can say a3 equal to 5. And then there is no error. I have a, I can do a plus a3 and get a result. Good. Now, these are very simple variables, but you can have a name which is area equal to 2.3. And so I have now a variable which is area. But what if I type area uppercase, right? This doesn't exist because area uppercase and area lowercase are two different variables. But of course I can define now an area, another area, which is 4.56. And so now I have two different variables with two different numbers stored in that. Okay, so names are case sensitive. You have also to know that there is a maximum length to the name of the variable, and this you can recover with the name length masks. Name length, and then I tap the tab so that Octave completes the name by itself, and then I see that it is 63. In your choice, you have to be careful because there are variables that are already predefined. They are built-in functions or variable. So for example, sinus is a function, and if you take sinus of 3 times pi, pi is also a built-in variable. It's the value of pi. And then sinus of 3 times pi gives you almost 0. Okay, if you take sinus of 3, then you get 0.1411. Now, what if you mistakenly type sinus of 3 equal to 2? Then Octave defines a new variable, sin, which has size 1 times 3, and whose the last entry is 2. Now, when you calculate again sinus of 3, you get 2 instead of 0.1411. If you want to recover the old variable or maybe function, you have to clean the variable sinus. So clear sin. And then if you take sinus of 3, you get again the original variable. So you have to be careful with these variables. There are also words which are reserved. We will see later what these are. But for example, we have for, and, functions, and many others. I just spoke about pi. Pi is the most known number. It's 3, 14, 16, or what it is. Here we see a short number of digits. So if I type format long, then I get more digits. So try now with pi, and I see many digits. This is still an approximation, but it's much better than the one before. In any case, the value of the variable didn't change. It's just the format that we changed. We can also change it to another format. For example, format long e, and then pi again, and I see that I still get the same amount of digits, but then there is also times 10 to the 0. So this e plus 0, 0 means 10 to the 0. So if I multiply pi by 10 or by 100, then I get 3, 14, 15 times 10 to the second. So this is the scientific format. There are other formats. Just type help format and you get many other ways of formatting your output.